In this video, we're going to take a look at a few examples of how to apply the laws of exponents to different problems. We're going to ignore this top column, adding and subtracting monomials, because we're going to cover that in Unit 7 rather than Unit 6. The first rule that we looked at is our product rule. So if I'm multiplying h squared times h to the 6th, we know that we have to multiply those bases and add those powers. So that's going to give me h to the 2 plus 6, which is really h to the 8th power. Anytime we have two more complicated expressions that we're multiplying together, we're going to multiply the terms that are common, so to say. So I'm going to start with my coefficients. 2 times -2 times 7 is -14. Then I'm going to look for the next thing that matches. So I have a squared times a cubed. We add those powers. We get a to the 5th power. The last one is b to that hidden first power multiplied by b to the hidden first power again. 1 plus 1 is 2, so that gives us b squared. Next, for our power rule, remember that we multiply the exponents. So x squared to the 3rd power, we're going to multiply 2 times 3, we're going to get x to the 6th. If we have a question like the next one, we're going to follow that order of operations. So remember that parentheses comes before the exponent, and then exponent comes before multiplication. So there's nothing that I can simplify inside the parentheses, but I do have this exponent that I need to simplify before I can do this multiplication. I'm going to raise everything inside the parentheses to the 2nd power. So -2 in parentheses to the 2nd power is equivalent to -2 times -2, which is 4. Then m to the 5th to the 2nd power means I'm going to multiply those exponents together to get 10, giving me m to the 10th power. Then we carry over the rest of it because we haven't used that yet. Once I'm finished with the exponent, I can move on to this multiplication and division step. Similar to the problem above, we multiply the common terms. So here I have 4 times my hidden coefficient of 1, which gives me 4. And then m to the 10th times m cubed will give me m to the 13th power. Next, we move on to our quotient rule. Remember that when we use our quotient rule, that means that when we divide like bases, we subtract the exponents. If I have coefficients in both the numerator and the denominator, I'm going to treat that as its own fraction and simplify it. So I'm going to look for a common factor between 27 and 42, and I get that common factor of 3, which leaves me with 9 over 14. Then I'm going to go ahead and deal with my next common term, x to the 5th over x to that hidden first power. When we divide, we subtract the exponents. 5 minus 1 is 4, so I get x to the positive 4th power. Anytime I divide, my answer always starts in the numerator, which means that if I get a negative answer, that negative exponent would be in the numerator, and then I would simplify it by moving it down into the denominator. If we look at our next example, again we have to follow the order of operations. Exponents come before division, so I have to simplify this numerator before I can deal with the y cubed in the denominator. Here we have our power of a power rule, so we're going to multiply those exponents together. 2 times 2 is 4, so we have y to the 4th over y cubed. Now I can use my quotient rule, which tells me that when I divide y to the 4th by y cubed, 3 of those powers in the numerator will cancel out, and we're just left with y, or y to the 1st power. Remember that any time we have a negative exponent, we want to simplify that by moving it to the other part of the fraction. If it's in the numerator, it moves to the denominator, and vice versa. Remember that the exponent only affects the term that it's directly next to, or the term that it's touching. There are no parentheses to bind the -5 and the x together, so this negative 2nd power only deals with the x. This is multiplication, so we have -5 times x to the -2nd, and we fix that negative power by moving it down into the denominator. So this becomes -5 times 1 over x squared, and we can simplify that even further to become -5 over x squared. For number 2, we're going to treat this the same as we did for the quotient rule. We start by just looking at the coefficients and reducing those. So we end up with 1 over 2. Then we have k squared divided by k to the 5th. Well, when we divide, we subtract the exponents, so that's going to give me k to the -3rd power. Again, anytime we divide, our answer starts in the numerator. However, this negative exponent means that our answer is not simplified. so that k to the negative third will need to move down into the denominator to further simplify our expression. That leaves us with just 1 in the numerator and then 2k cubed in the denominator. Lastly, we want to look at some examples with our 0 power. Similar to all the ones above, the exponent only affects the thing that it's directly next to or that it's directly touching. Here, this exponent of 0 is only affecting the x that's next to it. So 7 times x to the 0 power is the same thing as 7 times 1, or 7. If we look at this example, again we have to deal with exponents before we can deal with division. W to the 4th squared is the same thing as w to the power of 4 times 2, or w to the 8th. In the denominator, we also have w to the 8th. So if we subtract our exponents, we get w to the 0 power, which is equal to 1. Go ahead and pause the video and see if you can put all of our rules together to solve the first example. All right. We're always going to come back to our order of operations. So as I look at this fractional expression, I see a few things in the numerator that have to be cleared up before I can deal with the division and the denominator. So I'm going to start by simplifying my numerator. Here in my a cubed b cubed term, I have a hidden coefficient of 1. So I'm going to multiply that by the coefficient of the other factor being multiplied, 4. 1 times 4 is 4, so I'm going to have that in my answer. Next we have a cubed. I'm going to look for any other a terms being multiplied, and I see that I have a to the 4th. If I multiply a cubed times a to the 4th, I add those powers together, and I get a to the 7th power. Then I move on to my next term, b cubed. I see that I have a b to the hidden first power in the second term, so b cubed times b to the first is going to be b to the 3 plus 1, or 4th power. I haven't used my denominator yet, so that stays exactly the same. Now I'm ready to handle the division. In the numerator, I have a coefficient of 1, and in the denominator, I have a coefficient of 4, and in the denominator, I have a hidden coefficient of 1. 4 divided by 1 is 4, so that's going to be the coefficient in my answer. Then we move on to our variables. I have a to the 7th divided by a squared. Those are like bases, so when I divide them, I can subtract the exponents. 7 minus 2 is 5, so a to the 7th divided by a squared is a to the 5th power. I move on to the last term. I have b to the 4th divided by b to the negative 2nd. My base is b, so I'm going to write that down, and then since I'm dividing, I'm going to subtract the exponents. 4 minus negative 2 is 6, so b to the 4th divided by b to the negative 2nd is b to the 6th power. And this is my final answer. We're usually going to try to write the variables in alphabetical order from left to right in what we're considering our standard form here. Go ahead and pause the video and try the middle example. All right. Because we have these parentheses, this negative 3rd power gets applied to every single piece of the inside here. So instead of evaluating everything right away, I'm just going to write it down. We have 3 to the negative 3rd power. Then I have a to the hidden first raised to the negative 3rd. So we multiply 1 times negative 3, and we get negative 3. Then I have b squared to the negative 3rd. Again, it's power of a power, so I multiply those exponents together. 2 times negative 3 is negative 6, so b squared to the negative 3rd power is b to the negative 6th power. For the last one, we have c to the negative 3rd raised to the negative 3rd again. It's power of a power, so I'm going to multiply my exponents. Negative 3 times negative 3 is positive 9. Now I can see that I have several negative exponents that mean that my answer isn't simplified. The only thing with a positive exponent is c to the 9th, so that is going to stay in my numerator. Anything with a negative exponent is going to move down into the denominator in order to change the sign on the exponent. When I move this down, this becomes 3 to the positive 3rd power, a to the positive 3rd power, and b to the positive 6th power. The last thing I have to simplify is this 3 to the 3rd power. So I'm going to end up with c to the 9th over 27a cubed b to the 6th power. Go ahead and pause the video and try the last example on your own. When I have a question like this, I'm going to follow the order of operations, and start by simplifying whatever is inside the parentheses before I apply the exponent. So I start by looking at my coefficient. I have 2 divided by a hidden 1 here, so that's going to give me a 2. M to the 4th divided by m cubed means I'm going to subtract those exponents, giving me m to the 1st power. I have q to the 4th divided by q to the 3rd, meaning I'm going to do 4 minus 3 and get 1. And again, if it's 1, you don't have to write it. And then this p to the 0, anything raised to the power of 0 is 1, so that cancels out. When we're multiplying, we don't need to write the 1s. This whole expression is now going to be raised to the negative 2nd power. Similar to what we did in the second example, I'm going to apply this exponent to each term inside the parentheses. 2 to the negative 2nd, we're just going to write it here. M to the 1st raised to the negative 2nd power, where we multiplied 1 times negative 2, and we get m to the negative 2nd. And we do the same thing with q to the 1st. Raise it to the negative 2nd power, 1 times negative 2 is q to the negative 2nd. Now, each of these is a negative exponent, so that means this is all going to move down into the denominator of a fraction. When we move it down and there's nothing left, that means we have a 1 up in the numerator. The only thing left that we have to simplify is this 2 squared, and we end up with 1 over 4m squared q squared.